Hi everyone. This course is about object-oriented concepts in C++. Today we will have a brief introduction about C++. So let's start with today's agenda. We will first discuss information about the course, which includes the handout in brief and the recommended textbooks. Then we will point a few differences between C and C++. We will see how C is a subset of C++ and using C++ object-oriented methodology, more complex programs can be simplified. After that, we will see some basics of C++ like memory allocation, structs, enums, keywords, how a sample program is written in C++, and the different directives are used. Finally, we will look at C++ data types, the scope of variables in C++. We will discuss briefly about local and global variables. We will give an introduction to strings. In the end of the lecture, we will have a brief review and discussion on pointers and reference variables in C++. These are the recommended textbooks. Object-Oriented Programming in C++ by Robert Lefferre is a simple and basic book, useful for beginners. I would recommend this book to somebody who is knowing nothing about C++. C++ Primer Plus by Stephen Prata is an excellent book for understanding the concepts of C++ in depth. Thinking in C++ Volume 1 by Bruce Ickel is recommended for advanced level understanding if somebody has already knowledge about object-oriented programming concepts and basics of C++. This is the course structure. We will start with the introduction and basics of C++ today. This will be followed by object-oriented programming concepts. We will discuss in depth the concepts of encapsulation, abstraction, inheritance, and polymorphism. We compare these concepts with procedure-oriented programming. We will discuss several C++ concepts also, like classes, objects, function overloading, inline functions, constructors, destructors, and many more. We will conclude our lecture series with programs to practice and efficient programming practices. So let's start today's lecture. Welcome to C++. This exciting language blends the language C with support for object-oriented programming and for generic programming. This language is designed to cope with the escalating complexity of modern programming tasks using object-oriented programming. Its template features brings another new programming methodology, that is generic programming. The triple heritage, that is procedural, object-oriented and generic programming together is a blessing. It makes the language very powerful, but it also means that there is a lot to learn. C++ is derived from C language. Almost every correct statement in C is also a correct statement in C++, although the reverse is not true. The most important elements added to C to create C++ concern classes, objects, and object-oriented programming. C++ was originally called C with classes. However, C++ has many other new features as well. This figure shows the relationship between C and C++. Here, the different features to implement object-oriented programming are only available in C++ and not available in C. If you already know C, you will have a head start in learning C++, although much of the material will be new. To switch from C to C++, we need to know some of the basic similarities and differences between C and C++. Most of the things are similar, but small differences make a huge impact. Let's get started with the nature of language, which we already know. C is a structural or procedural type of programming language, whereas C++ is an object-oriented programming language and supports polymorphism, abstract data types, encapsulation, among others. Now, the point of emphasis. C++ emphasizes the objects and not the steps or procedures. It has higher abstraction level. C++ emphasizes the objects, not the steps or procedures. C lays emphasis on the steps or the procedures which are used to solve a problem. Next is mapping. Mapping between function and data can be done easily using objects in C++. Objects are the fundamental building blocks. Mapping between function and data is complicated in C. Here, functions are the fundamental building blocks. That is, C is function driven while C++ is object driven. Data is hidden in C++. That is, in terms of data security, data is hidden and cannot be accessed to external functions. Hence, data is more secure in C++, whereas in C programming language, data is unsecured. Then, the time of defining variables. In C, the variable has to be defined at the beginning in the function. In C++, variables can be defined anywhere in the function. Some more differences. The programs in C language are divided into modules and functions. The programs are divided into classes and functions in the C++ programming language. C does not support exception handling directly. It can be done through some other functions. C++ supports exception handling. It can be done using try and catch block. C does not support function overloading. C++ supports function overloading, implying that one can have name of functions with varying parameters. Same name of functions with varying parameters. Also, operator overloading is present in C++ and absent in C. So these are the few differences between C and C++. Let's see some more analogies between C and C++. The basic structure of C consists of hash include stdio.h in order to make use of printf and scanf functions, that is standard input output. Whereas C++ uses iostream header file hash include iostream. Writing comments is same in both the languages C and C++ using 2 backslash or 1 backslash star, again another star and backslash. C++ adds numerous additional keywords to support its new features. This renders C code using those keywords for identifiers invalid in C++, which means there are many keywords which are only included in C++. So if those keywords are used in C language as variables, then it won't be identified or invalid in C++. The example of new keywords which are there in C++ are new, template, class, bool, etc. So if we see this example, struct template, int new, struct template is pointed to class. So template, new and class, these all words are identified as keywords in C++, but they are not identified in C. So this is a valid C code, but it is invalid C++ code. It is rejected by C++ compiler. Since the keywords template, class and new are reserved, hence it is rejected by a C++ compiler. In C++, Boolean is a built-in type and reserved keyword. Now, coming to the dynamic memory allocation aspect. There are two ways that memory gets allocated for data storage. One is compile time or static allocation, where the memory is allocated by the compiler. Exact size and type of storage is known as compile time. The other is dynamic memory allocation, where memory is allocated on the fly during runtime. Dynamically allocated space is usually placed in program segment, that is heap. Dynamic memory allocation requires two steps. First we create the space, then store its address in a pointer. To dynamically allocate memory in C++, we use the new operator as shown here. Whereas in C, we used to use malloc. Similarly, deallocation is the cleanup of space which is used for variables or other data storage. Compile time variables are automatically deallocated based on their extent or scope, but the programmer should deallocate dynamically created space explicitly. To deallocate dynamic memory in C++, we use delete operator. In C, we used to use free. So, let's allocate memory to an integer array dynamically. This is the example. So, the array is initialized like this using this keyword new. Now, suppose if you have this array and you want to make it bigger, you cannot simply append new cells to the old ones, as we already know that arrays are stored in consecutive memory and you don't know whether or not the memory immediately after the array is allocated for something else. For that reason, the process takes few more steps. So I want to resize this array so that the array which is list, so the name of this array is list, has space for 5 more elements, assuming that the old one is full. So what are the steps required? Let us see. 4 main steps are required. First, this is our initial array, original array. We create an entirely new array with size of plus 5 elements. So we need another pointer. We are using another pointer temp for this. Now copy the data from old array into new array, keeping them in the same position. So here copying the same position data in the new array temp. So this is done via for loop. Now delete the old array. You don't need it anymore. So delete the array list is used to delete the initial original array. Now change the pointer. We still want the array to be called list. its original name. So change the list pointer to the new address. List is equal to temp. That's it. The array is resized. It is now 5 larger than the previous one and it has the same data in it that the original one had. But it has room for 5 more items. So this is how new and delete are used. Now come to another, that is structures and enumerations. C++ supports structures to remain backward compatible with C. But there are some differences in using struct and enum in C++. So if you see this example, you have a structure student with these variables. So in C, we need to use struct tag whenever we declare a struct variable. This is the struct tag. This is C declaration. So whenever we need to use this variable, we need to use struct tag. But in case of C++, the tag is not necessary. In C, we must use struct student for student variables. In C++, we can omit struct and use student directly. Next, the idea behind enumerated types is to create new data types which can take only a restricted range of values. So when you declare an enumerated type, you specify the names and the possible values it can take. For example, we declare enum suit which can take clubs, hearts, diamonds and spades. Only 4 values. If you are planning to use this in C, the above assignment will also need to prefix the declaration with the keyword enum. So here also you have to use the keyword enum. Thus enums are used in C++ also to declare a range of constant values without using hash define. So in case of C++, we need not use this. Next, we will see a simple program in C++ and compare it with C. The basic structure of these programming languages is shown here. In C, we include stdio.h header file in order to make use of printf and scanf functions. Execution starts from main in both C and C++. We use scanf to read input integer numbers and printf to do output the value to the output window. Now see how the same thing is done in C++. So here we use hash include iostream header file. Then instead of using scanf, we make use of cin, and instead of printf, we use cout object. See the difference here. Printf is a function here, cout is an object here. The two less than symbols, these symbols, are called insertion operators. It is an insertion operator function. We will study in detail later about this. So the first line of the program which we saw is hash include iostream.h. It is a preprocessor directive. That is an instruction to the compiler. A part of the compiler called the preprocessor deals with these directives before it begins the real compilation process. That is, this preprocessor directive hash include tells the compiler to insert another file into your source file. In effect, the hash include directive is replaced by the contents of the file indicated. A C++ program can be divided into different namespaces. So this is a namespace using. A namespace is a part of the program in which certain names are recognized. Outside of the namespace, they are unknown. So the directive using namespace std says that all the program statements that follow are within the std namespace. If we didn't use the using directive, we would need to add this std name to many program elements. For example, if you see this, we don't use this, we would need to say std : cout. But when we use using namespace std, then we can use directly cout. Next, functions. These are the fundamental building blocks of C++. When you run a C++ program, the first statement executed will be main. So in main, how does the function behaves? So the name of the function is main. It's the function name. The first line is the function header. This is the function header. The portion enclosed in braces, this entire portion, is called function body. The first line is a function header. The function header is summary of the function interface to the rest of the program. And function body represents instruction about what the functions should do. Each complete instruction is a statement and terminated with a semicolon. The final statement called return statement terminates the function. Here terminates the function. Next, the identifier cout is predefined in C++ to correspond to standard output stream. The standard output stream flows so the screen displays the output. Also, it can be redirected to other output devices. So if you see this, it displays the output on the display screen. This operator, insertion operator, directs the contents of the variable on its right to the object on its left. This shows the result of using cout and the insertion operator. Then cin statement causes the program to wait for the user to type in a number. The resulting number is placed in the variable num. So the keyword cin is predefined in C++ to correspond to the standard input stream. This stream represents data coming from the keyboard. Here this arrow greater than is the extraction operator. So this figure shows an input using cin and the extraction operator. Next, strings in C++. C++ provides a string class type that supports all the functionality to manipulate strings safely. So, we have a string class in C++. The C++ string class is part of the std namespace. That is why we use here using namespace std. So, if you see, you want to declare a string, you can usually use string str1 is equal to hello. You declare another string and then concatenate just by using plus operator. So strings can be appended easily by using the plus operator. Then you want to compute the length of the final string. To take length of the string here, you can use either length or size function, which are members of the string class. The point to be noted here is C++ is backward compatible with C. So it supports all the functions that manipulate null terminated strings in C, like strcopy, strcat, strlen, etc. Let's now look at the variables and data types in C++. C++ offers 7 basic data types, which are boolean, char, int, floating point, double floating point, wide char, and valueless. These basic data types can be modified using modifiers, which are signed, unsigned, short, or long. So the following table shows the keyword used to define the type and the bytes of memory occupied in a 32-bit environment. So a character data type will have keyword char and size of 1 byte. The integer data type is used to store integers and uses keyword int. If modifier such as short or long is used, the size and range or both of them changes. So when we use short int, the size is 2 bytes. Whereas when we use long int, the size is 4 bytes. A floating point data type stores real numbers. The digits of precision is 7 in case of float and the size is 4 bytes. Now we have double floating point where the digits of precision is 15 but the size is 8 bytes. Similarly, long double has a precision of 18 digits and size of 8 bytes. In addition to char data type, C++ provides another data type wchar_t, which is used to store 16-bit byte characters. The bool data type can hold only boolean values, which is either true or false. The void data type is used for specifying an empty parameter list to a function and return type for a function. That is, for void, no memory is allocated and hence it cannot store anything. So when we use signed or unsigned modifier, it shows positive numbers or both positive and negative numbers. In case of unsigned modifier, it shows only positive numbers and the range starts from 0. This makes them represent numbers twice as big as the signed types. The point to be noted is the size of all these types may vary depending on the compiler implementation. Now, scope of variables in C++. All the variables have their area of functioning and out of that boundary, they don't hold their values. The boundary in which they hold their values is called the scope of the variable. We can broadly divide variables in two main types, global variables or local variables. So global variable is that variable which once declared can be used throughout the lifetime of the program by any class or function. They must be declared outside the main function. Local variables are those which exist only in the function or the block where it is declared. Outside that, they are unavailable and it leads to compile time error. Now let's look at one example of global variables. They must be declared outside the main function. So here global variable x is declared outside the main function. If only declared, they can be assigned different values at different time in program lifetime. So if it's only declared, we can assign different values. Even if they are declared and initialized at the same time outside main, still they can be assigned any value at any point in the program. So if you see this example, here x is declared as a global variable. It is initialized with value 10 and then again initialized with value 20. So that's how the global variable can be defined. Now look at another example where we have local variable n. So this is a main, we have n which is declared inside the condition scope. This is the condition scope. If hence once the condition scope ends, the value of n also is unavailable. So when we try to print n again, we get a compile time error as n is not available here. The scope of n is between these two braces. Also there are some special type of keywords. So one is final, which is once initialized, value cannot be changed. Another is static. These variables hold their values between function calls. So these are the variables which are initialized and allocated storage only once at the beginning of program execution. A static variable retains its value until the end of the program. So if you are familiar with operating system architecture, local arguments and function arguments are stored on the stack, while global and static variables are stored on the heap. The following table summarizes the lifetime, visibility, and some other aspects of local, static local, and global variables. So the visibility of a local variable is inside a function, whereas the visibility of a global variable is inside one file. The local variable is uninitialized, whereas the static local and global are initialized to 0. The local variable is stored on stack, whereas the static local and global are stored in the heap. Now, we'll come to something interesting, pointers. C++ pointers are important to learn. Some of the tasks like dynamic memory allocation can be only done using pointers. To understand pointers, you should have knowledge of address in computer memory. A computer memory is broken down into bytes and each byte has its own address. For example, 1 kilobyte memory, we have 1024 bytes and each byte is given as address. So 1 kilobyte of memory, we have 1024 bytes and each byte is having its address. The ampersand operator can find address occupied by a variable. If var is variable, then ampersand var gives the address of that variable. Now let's look at the following example to demonstrate the working of a pointer. So what will be the output of the following program? So here in the first statement, a pointer is declared in pointer PTR. Now it is a null pointer as it is not pointing to any location. Then we have int a is equal to 10. Here we have initialized an integer type pointer and here we have initialized an integer variable. So how it can be shown in the memory? We have a value a which is equal to 10. It has some address. Then we have PTR which is yet not assigned. Next, PTR is equal to ampersand a. So now the pointer is containing the memory location of variable a. So the variable a has some address which is equal to this value. So the PTR is containing that value now. So this value is the address of a. So let's see the output of this program. We we define a PTR, we assign some value. PTR is equal to ampersand A. So Cout A will print 10. The value of A is 10. Cout PTR, which means the content of PTR is equal to this, which is the memory address of A, that is the content of PTR. Then ampersand A. So the address of A is the same as PTR, which is same as PTR. See, both the values are same. Then ampersand PTR, which means the memory address where variable PTR is located. So this is another memory where PTR is located. So we have a value, its address is stored in pointer. So pointer contains the address of another variable. Next, Cout pointer to PTR. So PTR will point to this value. PTR is pointing to this value here. Next, we have reference variables. A reference variable is an alias, that is another name for an already existing variable. So C++ references allow you to create a second name for the variable that you can use to read or modify the original data stored in that variable. Declaring a variable as a reference rather than a normal variable simply entails appending an ampersand to the type name, which is reference to an int. So when you create a reference, you must tell which variable it will become an alias for. So if you see this example, here int I is equal to 5. Here we are creating a reference variable which is alias to I. So the value of I and the value of the reference will be same. Output of this will be 5 and output of this will be also 5. The reference variable is an alias, which is another name for an already existing variable. So now, if you see one more example which uses reference to swap two variables, it will become clear to you. So here two integers are passed as a reference. Two integers are passed as a reference. The values of the original variables changes. So when we call this function swap, the values of the original variables changes and we get swapped variables as a result. So the values are swapped here. Both the arguments are passed by reference. The caller of the function need not be even aware of it. So when we can use references, how are they different from pointers? Both references and pointers can be used to change the local variables of one function inside another function. They can be used to change the local variable of one function inside another function. Despite that, there are following differences between references and pointers. References are less powerful than pointers. References cannot have null. That is, you must always be able to assume that a reference is connected to a legitimate piece of storage. References cannot be null, even though pointers are often made null to indicate that they are not pointing to any valid thing. Once a reference is created, it cannot be made later to refer another object. That is, it cannot be reseated. This is often done with pointers. Once it is initialized to an object, it cannot be changed to refer to another object. Pointers can be pointed to another object at any time. Next, a reference must be initialized when it is declared. There is no such restriction with pointers. Due to the above limitations, references in C++ can't be used for implementing data structures like linked lists and trees. We cannot have null references. Once it is initialized, it cannot be changed. And once it is initialized, only when it is declared. So, due to these points, references are also safer and easier to use. Safer because they must always be initialized, and easier to use as they don't need dereferencing operator to access the value. They can be used like normal variables. So, we end our lecture here. Thank you. The summary of what we learned today is some C++ basics, syntax for C++, the major differences in C and C++, how dynamic memory allocation is done in C++, a sample program in C++. We discussed the different data types and variables, and we had a brief review about pointers and reference variables in C++. The next lecture will focus on object-oriented programming concepts using C++. Thank you.